Okay, so we were working on this lab 30 when last we were in class together. And so as a reminder, what you are doing is you are exploding these two carts until they move and they hit, and you want to listen to when you hear them hit the sides at the same time. Okay, so once they hit it at the same time, you're going to put them straight back where they were. You're going to go ahead and measure these two distances, your delta x's, and then you're going to explode them a second time so that you can get the time it takes for them to travel that distance. So each trial, really, you're doing it twice, or maybe 3 or 4 or 5 times. You're getting it to where you can hear when they hit at the same time. And once you get that position set, take your measurements, explode it, calculate the time. Okay, once you have those pieces of information, you're going to come on down here. And so you'll have your x's and your t's. You can go ahead and calculate velocity, delta x over t. You can calculate momentum, mass times velocity. And you're going to do that for both cars, right? You're going to have your car that's going to the left and your car that's going to the right. Make sure that one of these columns is positive and one of these columns is negative, right? Because they're going in opposite directions. It doesn't really matter which is which. Just pay attention to that. Most of the errors that I have been seeing in calculating your momentum has to do with the mass. So be careful. Make sure that you've actually converted from grams to kilograms if you're getting weird numbers for your momentum. You're going to scroll down. You're going to make sure you answer all of the questions. When you get to the bottom down here, you're transferring the numbers from above into this column. And you're going to see when you add these together, this column plus this column, it should essentially be 0. Now, it won't be exactly 0, of course, because this is a lab situation, but it should be pretty close to 0 when you have those. Again, one entire column should be positives, the other column should be negatives. So I say you're adding them together, but you're adding a positive and negative. So really you're subtracting those two numbers. Make sure you answer all of the questions that are in the lab, and then you can go ahead and hit submit. When you're done with that, you're going to come back over to your packet, and I want you to work on some more of these explosion type problems. So the lab was your first little dive into that. We took all these notes the other day, right, about explosions. I'll slowly scroll through so that if you need to pause and take notes on those, you can. So we talked about explosions and collisions is where we have a conservation of momentum. We looked at an example. Our total momentum at the start is 0. Our total momentum at the end is 0 because it's an explosion. We did a little example problem in class. And now I would like to do one more problem, maybe 2, and then give you some answers so that you can try a bunch and check your work. Okay, so let's go ahead with this one. We have a 10 kilogram cannonball. It's shot out of a 1,000 kilogram cannon. If the cannonball is shot with a velocity of 50 meters per second, how fast does the cannon move backward, right? So the cannon is going to recoil in the backward direction, and that's what we're looking for, is to see like how much does that move. So P initial equals P final because our initial momentum is 0. It's an explosion, right? Nothing's moving at the beginning. And so since momentum is conserved, our final momentum will be 0 as well. So we're going to add up the momentum after the two things move away from each other. And so this is what we're going to do, is we're going to take our mass times velocity of the cannonball plus the mass times the velocity of the cannon. And we're going to set that equal to the total momentum, which is 0. So let's go ahead and do that. And remember, I've provided this video for you, so if you need to go back and look at it again on your own, you can. So 0 equals the mass times the velocity of the cannonball plus the mass times the velocity of the cannon and the mass and the velocity of the ball. So C is cannon, B is ball. Okay, so then we've got 0 is 1,000 kilograms times the velocity of the cannon, because that's what we're trying to solve for, and then we put in the other two variables. 10 kilograms, 50 meters per second. This is the one we're looking for. When we solve all of that, so you can subtract from each side and solve for your velocity of the cannonball, of the cannon itself, is a negative 0.5 meters per second. So do the algebra on that one and make sure that you're getting that correct answer there. Let me give you a couple more answers on this one so that you can try them and check your work. So for number 2, switch colors here. The answer, the velocity of the boat and the kid is a negative 0.54 meters per second. Signs matter, right? You got to look out for direction here. So make sure that you're paying attention to that. For number 3, Ben is sitting on ice, and he's got ski boots. Something that I want to call your attention to is that he throws both boots. So be careful about your masses there when you're solving. And remember that to find the mass of something, you need to know the weight, 637 newtons, and gravity, 9.8 meters per second squared. I'll help you out with this one. And so the mass there is 65 kilograms. That was a little tricky. The answer, the velocity of the boot, is a negative 0.83 meters per second. So try that one as well. If you're careful when you're setting it up, the signs will take care of themselves. So you'll be okay. And you're setting everything equal to 0. So I'll show you this one too again. So you're saying that mass of boot, velocity of boots plus, or Ben, and then ski boots. Well, I guess I'll just call it ski. I don't know, plus mass of ski boot, velocity of ski boots. So you're gonna set it up like that, just like we did with the first one. Okay, so work through that one. And then number 4, with the 2 skaters that push off of each other, our resulting velocity, the velocity of person 2, is negative 5 meters per second. And then something I wanted you to pay attention to this one is if you have less mass, you're going to have more velocity. Right? So if the bigger person pushes off, they push off each other, the smaller person's going to be going faster, right? Okay, so try those out, see if you can get the correct answer, and there is a Dropbox for you to turn them in. See you soon.